Okay. So this is the study of, you can say that. Okay, I'll make that one. Right triangles. Okay. So can I do this if it's not a right triangle? We can use aspects of this if it's not a right triangle. Okay. And again, then remember what we did with our special right triangles? We can use all that stuff in this case too. Four.
Is this the sine and tangent?
Yes.
Oh.
Sure. So, it has to be a right triangle, as we said. And this is where it's probably really important that we draw this triangle not necessarily consistently the same, but labeling it the same. So you always want this to be C, meaning the right angle. And again, it doesn't necessarily have to be, but then we can relate it back to the Pythagorean theorem really easily, right? A squared plus B squared equals C squared. But the most important part of all of this right here is that, going back to what we said a while ago, that the angles and the opposite sides go together, right? The angles and the opposite sides go together, meaning the label of them. So if this is capital A up here, this down here, yes, you can call it CV, but you can also call it lowercase a. And this is important again. This is more important probably when we get into the law of sines and cosines, which is a couple days away. But just so you start recognizing this. And again, to me, this means that this capital A is in that corner, and then little a is opposite of it or across from it, right? So that's a word that we really have to make sure that we understand. So we want to emphasize that word. So in trigonometry, the two important words are opposite. And again, to me, that means it's diagonal from. The angle that we're talking about. And then the other word that's really important is adjacent. And we've talked about this, right? Adjacent, we talked about when we talked about angles. What's adjacent mean?
Next to each other.
Next to, okay? Now here's the key to all of this. You can have opposite and you can have adjacent. My third side then is going to be my hypotenuse. And this is where some people get confused. But if it's the hypotenuse, it can't be opposite or adjacent. Hypotenuse is hypotenuse. So if you're looking for adjacent, and it's adjacent to two sides, obviously, right? The angle is going to be adjacent to two sides. But if one of them's hypotenuse, then it's got to be the other side, because adjacent can only be the other side. It can't be hypotenuse. Make sense? Ariel?
Yep.
Make sure you let me know if you have any problems. Okay. So, what are my three signs? So from here then, we're going to talk about something called trigonometric. That's a fun word to say, right? Trigonometric ratios.
I come back in.
So if we say that this is a ratio, what does that mean?
Fraction.
It's going to be a fraction. So whenever we talk about trigonometric ratios, we're talking about trigonometric fractions. And that's where the word comes about. Okay? And that's where we're going to use these words also. Opposite, adjacent, and hypotenuse. So our three trigonometric ratios then are what?
Sine, cosine, tangent.
Okay? So here's the other thing that you don't realize probably. Sine is actually that word right there. Right? Cosine and tangent is written as an actual word, but usually we show it as the abbreviation. And ladies and gentlemen, it's a sin to call it sin. So don't call it sin. This is sine. Alright? my abbreviation for cosine, and my abbreviation for tangent. Now, so we're going to build a fraction. When you use these words, this is really important to get it into your melons. When you use the word, an angle should go with it. Remember, angles are always with capital letters. So this says I'm going to find the sine of A, or the cosine of A, or the tangent of B. All right? Big star down here. You cannot find the trig ratios from the 90-degree angle. It just doesn't work. So there's only two possible angles that you can do the trig functions to. Sine, cosine, and tangent. So everybody, right now find your sine, cosine, and tangent buttons on your calculator. That should be right in the middle, right? Okay? Even on most of your smartphones now, if you turn it to the side, you can still find these things, right?
Yeah.
Okay? So you can use your phone. The most important thing that you got to realize is how you use the buttons on your phone or on your calculator. On your phone, a lot of times, well, even nowadays, you can hit sine and then a parentheses comes up. Okay? On most phones too. But sometimes you put in the fraction first and then hit the button. So you just got to know how yours works. All right? And we'll go and get into more of that in just a second. So, our trigonometric ratios are our three things. And how do we remember them? Is our word, right? So the word's fun to say, right? SOHCAHTOA. But the most important part of SOHCAHTOA is what? That you spell it right. If you don't spell it right, it's no help to you. Okay, so you got to make sure that you spell it right. Now, why did I write it this way? Because the capital letters are the three trig ratios. The lowercase letters are going to tell you the sides that make up your fractions. Okay, so remember, anytime that you write the word sine, cosine, and tangent, the next thing right after that should be a degree measure or an angle. Then each of them are set equal to a fraction. And the fraction is what we're going to use the little letters for. Okay, so the fraction for sine is O and H. Well, what do O and H stand for? Opposite over hypotenuse. So I'm going to have the opposite side over the hypotenuse. Ladies and gentlemen, you are not using your calculator for this. You are not punching anything into your calculator for this particular kind of problem. You're simply making a fraction. Okay? You are not using your calculator. Okay? So, what's cosine? The adjacent side. And again, we're always talking about sides. So the sides should give you lengths. So the adjacent over the hypotenuse. And then finally the tangent is what? And again, this is the most important thing, that if you can't spell the word SOHCAHTOA, then you got to figure out a different way of remembering it. Okay? So again, now we're going to do the opposite over the adjacent. Now, when they talk about this in the book or on the quiz or on the test or whatever, they're going to say find the three trig ratios as a fraction and as a decimal. Okay? So you're going to build your fraction by using the lengths of the sides that are given to you. And then to do it as a decimal, again, this is where it's kind of confusing. You're not going to use the buttons on your calculator, meaning sine, cosine, and tangent, but you might have to use the button. You might have to use your calculator to turn your fraction into a decimal. Meaning if it's 2 over 7, then I'm going to punch 2/7 into my calculator. So technically I'm using my calculator, but I'm not using the word sine, cosine, and tangent yet. That makes sense what I'm saying? So you got to make sure that you read the directions also for what you're going to round to. So they're going to say find, in all honesty, there's 6 trigonometric ratios. We only concentrate on 3 because they're the ones on the calculator. If you take pre-calc and calc, you'll get into the other 3. They're the inverses of, so you can flip them over. But that's past our pay grade right now. Okay? So make sure you follow the directions. Okay? So let's try one of these. We'll just make it up. So we draw a right triangle. I don't care what it looks like. That's all I really need. Okay? And I don't even care what the angles of the other 2 are. I mean, I don't care what angle A and angle B are. All I care about is if I know that, I think I said 2/7 the other day, or in the other one. If I know that this is 7 and 2, can I find my hypotenuse?
Yes.
Because I just do what? Pythagorean theorem, right? 2 squared plus 7 squared. So what's 49 plus 4? And then I'd have to take the square root of it, so technically it's the square root of 53. Everybody agree with that? Okay, so this one's going to be a little bit more complicated because I just made it up on the fly, but it's okay. Don't freak out about it. Okay, so again, when they ask me to find the 3 trigonometric ratios and write it as a fraction and as a decimal, I'm going to say the sine of. And then they're going to give me specifically what angle they're looking at. So this is, again, important. I can't do it from the 90-degree angle. So let's just concentrate on the sine of A. So basically, I'm going to A angle, which is this angle right up here. And now I'm going to do my trig function, which is sine. So from that angle, I'm going to look at the opposite side and put it over the hypotenuse. What's the opposite side? 2. And what is my hypotenuse?
Square root of 53.
The square root of 53. So, if this ever happens to you, I still have to rationalize my denominator, right? So then I would go through and do this part. So again, this is probably not a real great problem to start out with, but it'll work. So we'd get 2 square root of 53 over 53. Then we would punch this into our calculator. Again, we're not using sine whatsoever. Somebody punch in, probably you can just do this. Somebody punch in 2 divided by the square root of 53. And we're going to use this symbol now. What's this symbol mean? Approximately. So whenever we have these numbers, we're going to probably round. And that's where you got to read the directions again. What'd you get? 0.27. 0.27? Thank you. So make sure you read the directions. In this case, they'll probably ask you to round to the tenths or the hundredth spot. 1 or 2 spots. Okay? But again, I never used the buttons on my calculator yet. Are all good with that? Okay? So, go ahead and find the next one. Cosine of A. So now, again, I'm still concentrating on A. Cosine says I'm going to use which 2 sides? The adjacent side and the hypotenuse. So again, this is where, notice from A I have 2 sides that are adjacent, right? But one is hypotenuse, so the other side has to be adjacent. So now we're going to have 7 over the square root of 53. So again, we would expect you to simplify this and say 7 square root of 53 over 53. But then when you're asked to write it as a decimal, you can just come back and punch that into your calculator. Now again, here's another situation where you better make sure that you understand how to use your calculator with radicals. Okay? Most of the time when you hit your radical button, they should probably come in like this and leave it open-ended and put an X there and you're filling in that X. Most of the time, like if you're just punching this into your calculator, you do not have to close that radical off in your calculator. If you leave it off, you better not put anything after it. Meaning don't say plus 7 or times 14 or something. Because if you leave it open-ended, they're not going to take the square root of whatever number is in there. Okay, so your calculator, you always think that your calculator is so smart, but your calculator sometimes doesn't understand what you're trying to punch into the calculator. Okay, so what was this one? As a decimal. 0.96. And then finally, we'd have what? Cosine of?
Tangent.
Oh, no, tangent. Thank you.
Tangent.
I already did. Tangent of A. And we get what? So again, I come back to tangent. Tangent says we're going to do opposite over adjacent. So opposite over adjacent, which is?
0.28, or 0.29.
0.29. So we get 2/7 and 0.29. Right? Now, sometimes they'll tell you to find the 6 trigonometric ratios. What that means is you actually have to do it from A and B. So I do them all from angle A, which we just did, and then we do them from angle B. Well, if you do angle B, basically what's going to happen is these two are just going to flip-flop. Okay? Because if I do B and I do sine, that's opposite over adjacent, which is actually the cosine over here. And so it's kind of simple if you actually have to do both of the letters, A and B. Because if you do the first one, then you're just flipping those two over. And then for tangent of the second angle, you're just taking that fraction and flipping it over. And I can never do it from C. Because C is my 90-degree angle. Okay? Okay, bro.
My mind just thinks so.
Do we need to see another one like this?
Yes, please.
Yes? I'll try to make it a little simpler. That one's probably a little more complicated, and probably more complicated than we'll get into just because of the radical. But, 15, 17. So, again, it doesn't matter what my angle is. Now, if they give you this triangle right here, would you say this is in the right, those numbers are in the right spot? Right? Because this looks like it's my shortest side, so it should probably have the smallest angle, or sorry, side. Realize still, again, if we call this, it doesn't matter what we call it. Let's call it X, Y, and Z this time. So sometimes they might not even use A, B, and C. Okay, so again, I cannot do my trig functions from Z because it's the 90-degree angle. Okay? But realize, if I asked you now, what is the smallest angle, it should be what?
X.
Angle X, right? Because it's across from it. Okay? So, if you want to try this out, now I want you to find the 3 trigonometric ratios, write them as a fraction and a decimal from angle Y. From angle Y. So here's your angle right here. Remember, I gotta have it from an angle. So I would say that I'm gonna find the sine of Y, the cosine of Y, and the tangent of Y. And I'm gonna write it as a fraction and as a decimal. You got this now, right?
Yes, I am. I'm gonna write it down.
Alright. So what's sine? 15 over 17. Everybody agree? From Y, opposite over hypotenuse. What's my decimal? 0.89?
What's around that?
Depends on what they ask you to run it. 882.
Yeah,
Cosine.
Gator was 1817.
Say it one more time.
0.47.
And tangent.
15 over 8. And then 1.875. 875. Yes.
So again, just make sure that you read the directions to see what they ask you to run. It's probably going to be 1 or 2 decimal places for this part. This is where also it gets a little confusing because they're going to ask you at different times how to, or different places to round to different things. And we know how some of you like to read in the first place. Now you actually have to read the directions in all places because they're going to switch. Okay? So remember when we did this, if they ask you to do this, I want you to do the sine of 60 degrees. What should automatically click in your head if they say the sine of 60 degrees?
Option.
You should go back to thinking about our special right triangles that we talked about the other day. So if I'm going to do the sine of 60 degrees and they ask me to write the trig functions for this, I'm still going to make my right triangle. I know that this has to be 30 up here, that this should be 60 over here because of the lengths of the sides. So when they say the sine of 60, I'm thinking about that angle right there. But I'm going to use the ratios that they gave me. So what were the ratios and where should they go if this is my 30, 60, 90? 1, square root of 3 and 2, right? So what is the sine of 60 degrees? So go to 60 and what's the sine? So the sine is what? 2 sides. So what's opposite of 60?
Square root of 3 over 2.
So we'd say the square root of 3 over 2. So when they ask you, and I think you have to do this in your assignment today, if they ask you the sine or cosine or tangent of either 30, 60, or 45, you can go back and you can do the same thing, but you can also just do it with the ratios. Okay, and it's going to work out all the time. So if it's a different number, then you would just plug in the numbers later, but you know that you're just going to do it with the ratios. Okay, and I know that always confuses people. That's why I told you that.
So there's like numbers on there.
So then you just do it.
They won't give you numbers with those.
What if it's like
So then you just do it normally.
If it's 52 degrees, we'll get to
It's
that.
not one of these.
We're getting that right now. Okay? Alright, questions. So again, this is not giving you any of the degree measures, right? We don't know what they are, they're just telling us that it's an angle. Alright? So this is where everybody was like, well, I always want to use my calculator, right? So get your calculator out. The first thing that you got to do is go to mode, I believe. So find your mode button. Okay. Mine's about the third one down. It says radians versus degrees. Do you see that?
Shut up, Bruce.
Where's my
Doing
card?
degrees right there, Scott.
Yeah.
1 week from today is his anniversary of his dad.
Let's go.
Bruce.
You see how it says?
Oh, yeah.
So, if you have a calculator like this, the button is a DRG button. It says DRG on it. If you hit that button, 3 things should come up. Okay? You want to make sure whether you can do it like this and get radians and degrees, or like Shayla's, you want to make sure that yours is on degrees. If yours is on radians, you will miss every single problem in this chapter. And then you'll yell at me for it. Okay? So make sure your calculator is on degrees.
These calculators. I mean, you are not worthy of really Bruce's calculator. Only 3 kids.
You just made fun of it.
You know, I would say something, but it ruined it, so I'm not doing it.
What?
I have to put this out while we use it.
I don't know, I have to look at it.
You just made fun of it?
Yeah. If the first one doesn't give you the same answer that we have,
The camera?
then look at somebody else's. Okay? It's already right there, Joe.
What?
So if it says DEG on your screen somewhere, you are in degrees. If you got a calculator like this, or you borrowed one from up here. Okay? It should say DEG along one of the sides, or either on the bottom or the top. Okay? Everybody good? So, when do I get to use my calculator? I get to use my calculator when they give me a problem like this. So, use calculator. Now obviously when we're saying use your calculator, we're meaning the three buttons, sine, cosine, and tangent. Because obviously we used our calculator in the last two problems too. But we're actually saying these buttons. Okay? So you're going to use your calculator anytime a problem is given to you with one of the three words, sine, cosine, and tangent, and then a number in degrees. So basically what is going to happen when you punch this into your calculator, you're just going to hit, and now again, this is where you got to know how to use your calculator, but most of you should now just be able to hit sine of 43. And if you notice, they gave you an open parentheses at the beginning, but they didn't close the parentheses off at the end. You notice that on your calculator? I would honestly get used of closing it. Why? Because in some of the problems here that we're going to work on, there's more to the problem. And so if you leave that open and then write times 27, for instance, it's not going to take the sine of 43 and then multiply it by 27 unless you close the parentheses off. Does that make sense what I just said? Okay? So get used to closing your parentheses, even when you're just doing these problems right here. Now hit enter or equals or whatever, and you should get a long decimal. Right? So, if you did not get 0.68199836601, your calculator is still not in degrees. Okay? Now, when you do these problems right here where you can actually use your calculator, they're going to tell you to round to 4 decimal places. So, again, I've said this more than once, we are horrible at rounding as a school. So if we're supposed to round to 4 decimal places, we need to look at the what number? The 5th number. If the 5th number is 5 or higher, we're going to make the 4th number 1 bigger. If it's not higher than 5, we leave the 4th number the way it is. So we would actually say what here? 2, and you really don't need that 0, right? But you can put that 0 there. Okay? So again, anytime from here on out, they give you one of the trig ratios, and they give you a number that is a percent, you're going to punch it into your calculator. So what's the cosine of 84 degrees?
0.10452846.
So again, 4 decimal places.
4 decimals.
1045.
Everybody agree? Okay? Now, this is where a lot of people are like, well, what's this mean? And so on and so forth. This is exactly like what we just got done doing. Okay? See how it said the sign of what gave us a fraction? And then we took that fraction and made it into a decimal? That's essentially what we're just doing right here. This is actually that decimal number of the fraction. But we're just finding it in a different way.
So like 43 like a
43 could have been the B angle if it would have fit with those sides. Absolutely. So instead of saying these sides, they could have just put 43 right here and then done that. But then you could go through and try to figure out the sides by trying to figure out the fraction, but that's really hard. Okay? But essentially it's the exact same thing. Does that make sense? So when do I get to use my calculator? When it's one of the ratios with a number degree. So it's actually acting like the angle of a right triangle. Yes.
But when they give us a 60-degree
You can do the coast, or what did I have up there, sine of 60 degrees?
Yes.
What did we say the sine of 60 degrees was? Square root of 3 over 2, right? Somebody punch in the square root of 60 in your calculator right now. Somebody else punch in square root of 3 divided by 2 in your calculator.
Square root of 60 was 7.746.
It's 2.7, right?
7.7. Square root of 60. Oh my gosh.
Square root of
Square root of 60
three over
is
two.
8.6.
It's 0.866, yeah.
0.866.
Square root of 3 over 2.
Divided
Mine just gives me,
We got one.
mine's in the same thing as Eric's.
2.
Square root of 3 divided by 2 is 0.86. 0.87.
You're gonna take the square root of 3 first and then.
Yeah, but you got the square root of 60.
No, you were supposed to do sine.
Sine of 60.
Oh, I thought you said square root of 60 is 0.866.
Sine of 60 is 0.866.
Yeah.
Now, what's the square root of 3 over 2?
0.866. 0.86.
So it's the exact same thing.
How do you change this one? So just give me the value. It doesn't go out in the decimal.
Yeah.
I just.
Square root of 3 over 2.
Yep. I don't think I got that. You know, if you just press clear,
Go down to, go to low again,
Okay.
and go down all the way to the bottom.
Yeah.
It says what, classic, I think?
This is real. Yeah.
Let me see.
Oh, yeah.
Yeah, K classic.
So it shows the decimal value comes in 72.
For what?
For what? 70 right there. Right here.
Yeah.
You can fix that. I'll look at yours again.
I
I'll
like
split
the
it.
side, like the
Oh.
side, it does this.
Okay. Alright, so it's the exact same thing, right? And so you're doing the exact same thing, it's just two different ways of doing it. Everybody good? Okay? So, the next thing that we're going to try to do is solve a problem.
Nice, well,
So the next thing that they're going to do is they're going to give you a triangle, and they're basically going to ask you to solve the triangle. Okay? Well, okay. So, if they asked us, and give us one of these again, and they tell me that this is 25 degrees, and they tell me that this is 17 degrees, and they want us to find this. So they're asking us to solve a right triangle. Okay? So basically, anytime that they tell you to solve a right triangle, they're telling you to set up a problem. Okay, so if we're going to do this now, we're always going to try to include an angle and then two of the sides by one of these three things. That makes sense? So remember, the angle, the number angle, always has to go with the word, right? So we're going to fill in some word here, meaning sine, cosine, or tangent, of the angle that's equal to, and then you're going to look at the other information that they give you. Well, they want you to find x, and they give you this 17 side. So what relationship does the angle, this side, and this side have that would link you to one of those three things? That's what you got to think about. So we got what? Adjacent, and obviously this has to be hypotenuse. So which one's adjacent and hypotenuse? So we're going to fill in the word with cosine, and then we're going to set up our fraction still. So what would we set up? 17 over x. Now, all of you are always looking for a shortcut or some place that you can kind of cheat the system. So I'm going to tell you a big cheat here. Okay? If you would go through the process of trying to solve for x, you would have to go what? Well, I'd have to multiply by x on this side, and if I do that on this side, then these x's cross out, then I have this, and then I'm going to divide by the cosine of 25 on both sides. And how many of you are going to actually do that or remember to do that? Probably Shayla, okay? The rest of you are going to take the time to even try to do it. So, if we have this problem right here where we have cosine of some number, again, this has to be an angle, which was 17 over x. So my variable is in the denominator. All you are doing is the old switcheroo. So to make this problem solvable, I'm going to switch cosine of 25 and the denominator and make it into 17 over the cosine of 25. What I did before would have gotten you this anyway. I'm just showing you the shortcut. Okay? Now, this is really, really important. So punch this into your calculator and practice. Because you got to see if you need to close this 25 off or not. So everybody punch it into your calculator right now. You should be able to do this all at one time. So let's take 17 divided by the cosine of 25. If that's confusing for you or your calculator is kind of weird, you might have to punch in the cosine of 25 and then hit 17 divided by that decimal.
How many decimals is allowed?
That one's probably only one or two of them. Okay? So we'll pick up back up here tomorrow and finish this. Okay?